This is a lesson video for 2.8, which is about something called literal equations. The idea is that after you've solved a lot of equations with numbers and one variable, that we should be able to use those skills to apply another idea that we need in math and science. Some equations need to get moved around. So our objective today is to be able to take a formula and to be able to move it around so that it's solved for one of its other variables. What we mean by that is that an equation with a variable is said to be solved for a certain variable when it's isolated on one side. Take a moment. Always pause the video if you need a moment to get your notes caught up. The formula in the tables, or each formula in the tables, is solved right now for a single variable. What that means is a single variable is alone on one side of the equation or the other. And when we use that verbiage, solved for a variable, then what we can tell is that in that first formula, the variable that's isolated on one side is the one that it's solved for. So in the first one in the table, it's solved for A. In other words, area is what this formula outputs. Pause the video right here, find what the other four equations are currently solved for, and then come back to the video. If you're back on the video, it means you filled these in. That second equation is solved for Y, the third one for D, the fourth one solved for Y, and the fifth one currently is solved for P. Our goal then in this video is to figure out how to use our equation solving skills to move those equations around to be solved for a different one of the variables, so that instead of outputting possibly perimeter on the last one, maybe it would output width or length. So in the next part, you're going to solve the equation for W. And what that means is that you're going to use your equation solving steps that you know how to do, which think of SADMEPs, subtract, add will undo, then multiply, divide will undo, to get that W alone on one side through good algebra. W will then become the output to this formula instead of P, which is the current output. The way it would be phrased in homework would be solve for W. So as I look in the formula that's already printed, I can see where W is, and I need to use that equation solving idea of doing things to both sides to first undo any addition or subtraction that's being done around that 2W term. Then I'll undo any multiplying divide that's happening to W to get it alone. So our goal is to have a W equals equation by the time we're done. So according to SADMEPs, the first thing I would do is I'd subtract that 2L on both sides because that's the current thing that's keeping 2W from being alone. When I do that, I'm going to get perimeter minus 2L equals 2W. Then I'm going to take that next step of multiply and divide and undo that by dividing both sides by 2. My remaining equation then isolates W on one side because the 2's would cancel. Oops, did not want to do that. Let me try that again. And then on the other side, it would be the P minus 2L all divided by 2. That would then be our equation solved for W. Using that equation now, that equation is ready to take perimeters and lengths and use them to spit out W. Sorry, did not mean to bobble that. So in here, I want to take the equation that we already know about, because we know about this equation. And in for perimeter, I want to put the information they gave me, 84 centimeters. And in for length, I want to put 18 centimeters, and this formula is already set up to find me a width. So when I go to plug all that in, here's what it looks like. Calculating that then, the width is 24 centimeters. And in math and science, if we have to do a lot of calculations with a formula, it's often a good thing to move it around and get it solved for one of the variables so that it will output the variable that we need. You're going to try a few. So pause the video, try a few of these, and only come back when you've tried all three, and I hand wrote one of those in to look at. If you're back, then let's look and see how you did on the first one. The first one is length times width, but they'd like us to isolate or solve for the length in there. Since it's length times width, what I would like to do is undo this by dividing both sides by W. When I do that, then my final result is going to be that I've got area divided by width equals the length. On the next one, I would have divided by radius on both sides, by R, and I would have gotten that D divided by R is T. So each of those were a one step. There was only one thing to do in order to get that variable isolated. This last one, though, has several things. And because there's a fraction in there, I might start by first dividing or multiplying both sides by 3 to undo that thirds. I would end up then with 3v equaling 4 pi r cubed. The pi r cubed, or the r cubed, is what I'd like to get alone, so I divided both sides by 4 pi. And then my final value, in other words, r cubed alone on one side, is 3 times v divided by 4 pi. A formula that's used really often to convert between Celsius and Fahrenheit is listed in this problem. Fahrenheit temperatures can be calculated by 9/5 the Celsius temperature. Celsius is used in almost every other country except the US, and add 32. A lot of hospitals now are using Celsius, even in the United States, so if you're thinking of something in healthcare, this is something you might want to be familiar with. So Fahrenheit represents the degrees in Fahrenheit, the temperature system that we typically use in the US, and C represents that temperature in Celsius. We'd like to solve that formula for C. So bring down the formula first. And when you bring it down, you want to think about what's going on in there. When you bring that formula down, it's got 9/5 C plus 32. So the first thing I want to do is subtract that 32 on both sides so that I then have an expression where the subtract is already taken care of. So I now am up to this part where it says F minus 32 is 9/5 C. It's not my final answer though. So what I want to do is think about what's got to happen next. So I already took care of the adding and subtracting. Whoa, that's a huge mess with that, isn't it? So let's try that again. I already took care of the adding and the subtracting. So now I need to take care of the undoing the dividing and multiplying. So on that 9/5 side, I'm going to multiply both sides by 5. When I multiply this subtract term by 5, I need a parenthesis so that it will distribute over the 5. The 5's cancel on this side, so I've got 5 times, and you can distribute if you'd like, I'm not going to, equals 9C. The last thing I'm going to do to get C alone then is divide both sides by 9. C will be alone on this side. And then on the other side I'd have, and I'm going to leave. There's not a single number that's going to come from this. It's moving it around. That's the new skill. So there's my new formula that solves, that takes F values, Fahrenheit values, and turns them into Celsius. Then the last thing is to actually use that Fahrenheit formula now to find the equivalent temperature for us, for one that we know. So this formula is going to spit out a Celsius temperature. We'd like to know if it's 99 degrees Fahrenheit, a nice warm day, what that would look like in Celsius. So as I bring down my formula said it's going to be 5 times the quantity F minus 32 divided by 99. So it's going to be 5 times the Fahrenheit temperature that I'm interested in inputting. 9. And that equals a Celsius temperature that you're going to have to round a little bit, of around 37.2 degrees Celsius. So a nice hot day when you're traveling in another country that uses Celsius will be a 37.2 degree day.